Welcome to geometry class. Today we are going to begin a new unit and we're going to be talking about transformations. There's several different types of transformations that we are going to learn about. The first type is called a translation. A translation could also be referred to as a slide. We're going to take a shape and we're going to slide it somewhere else, okay? So this problem says record the coordinates of the vertices of the original quadrilateral GEOM in the table below. So I'm going to look to see where these points are. G, and remember we count the jumps when we're working on the coordinate plane, is at negative 1, 2, 3, 4, positive 1, 2, 3, 4, 5. Negative 4, 5. E is at 1, 2, 3, 4, 1, 2, 3, 4. O is at 1, 2, 3, 4, 1, 2. And M is at 1, 1. So on step 2, it says on the graph above, translate or slide the quadrilateral 6 units down. Use the vector, and it has these little chevron symbols. Those are kind of like parentheses, but they're pointy. 0, negative 6. So the 0 changes the x, so there's no change to the x. The y changes by minus 6. So that's when it says use the vector, that's what it's saying. The x isn't going to change at all. The y is going to be minus 6. Label the corresponding vertices G prime, E prime, O prime, M prime. The little slash marks up at the top are red prime, and that shows that that is our new transformed shape. So we're going to do a transformation of translating the shape 6 units down. So for point G, I'm going to count down 1, 2, 3, 4, 5, 6. There's my G prime point. And we're going to, for step 3 here, record the coordinates. So I'm going to go ahead and do that as I go. So G prime is at negative 4, negative 1, because it's same x coordinate, but the y is 6 less. Now for E, I'm going to go down 1, 2, 3, 4, 5, 6. Here's E prime. It's at 4, negative 2. O, counting down 6, 1, 2, 3, 4, 5, 6. Here's my O prime. It is at 4, negative 4. And M goes down 1, 2, 3, 4, 5, 6. So M prime is at 1, negative 5. Okay? And we can connect all of our points using a ruler to make it look nice and sharp. Or if you don't have a ruler, you could use maybe the side of your student ID or driver's license or the side of your notebook. Anything that has a straight edge on it. It's a little bit sturdy. Okay, so this is my translated shape. It went down 6. It says for number 4, what happened to the x coordinates under the vertical translation? Well, look, the x's are the first number and the y is the second number. So all the x's are exactly the same. So they stayed the same. And what happened to the y coordinates under the vertical translation? Well, 5 minus 6 is negative 1. 4 minus 6 is negative 2. 2 minus 6 is negative 4. And 1 minus 6 is negative 5. So they decreased by 6. Or you could say we subtracted 6 from them. Okay, however you want to word that. So write a transformation rule that describes the vertical translation. X stays x, but y is the y value minus 6. So this is how we translated the shape vertically with a function rule, a transformation rule. Okay, let's look at the next one. we're going to do a different type of transformation here. We're going to do a reflection. So a reflection, if you think about when you look in the mirror, that's your reflection. It looks the same as what you do. But a reflection in our coordinate transformation unit is going to be like maybe like a flip. You flip the shape across a line. So the first step says to record the vertices of the original triangle TRY in the table below. So my point T is at -1, 2, 3, -1, 2, 3, 4, 5. My point R is at 1, 1, 2, 3, 4, 5, 6. And my point Y is at 1, 2, 3, 4, 5, 6, 7, 1. So it says, on the graph above, reflect the triangle across the y-axis. So remember, your y-axis is this one that goes up and down. So this is the one we're going to reflect it across. The x-axis, of course, is the one that goes side to side, but we're reflecting this across the y-axis, the vertical axis. Label the corresponding vertices T prime, R prime, Y prime. So the way that you reflect it across the line is you take each point and you figure out how far away from the line is it and go that same distance away but on the opposite side. So I can see point R is 1 unit to the right of the y-axis. So when I reflect it across the y-axis, it will go 1 unit to the left of the y-axis on the opposite side. My point Y is 7 units to the right of the y-axis. So when I reflect it, it's going to go 1, 2, 3, 4, 5, 6, 7 units to the left of the y-axis. Now point T already is on the left side of the y-axis. It's 3 units away. So now it's going to be 3 units away on the right side. So 1, 2, 3. There's my T prime. And then I can use my ruler to connect the points. So this transformed triangle overlaps the original one a little bit. It's kind of like if you were to fold it along the y-axis, it would match up on both sides. So we have to record the new coordinates of the shape T prime, R prime, Y prime in the image column of the table. We have the original figure and then we have its image. So T is now at 3, -5. R is at -1, 6. And Y is at -7, 1. So what happened to the x coordinates under the reflection? Well, this was -3, now it's 3, this was 1, now it's -1, this was 7, this is now -7. So the signs changed, and the way you could make a sign change is by multiplying those numbers by a -1. So I'm going to say they were multiplied by -1, which is the same thing as changing their sign. Now, what happened to the y coordinates under this reflection? Well, the y's are exactly the same as what they started, so they did not change. Okay, so last it says to write a transformation rule that describes the reflection. So the x's became that x value times -1, which is -x. That doesn't mean there's always a negative, because if it was negative and you multiplied it by -1, it becomes positive. That negative in front of it basically just changes the sign. What if it was negative, now it's positive. If it was positive, now it's negative. Then the y coordinates stayed exactly the same. They did not change at all, so they stay y. All right. The next activity is about rotations, and I am going to come back to this in our lesson next time because we are going to take a deeper look at rotations in our next section. Okay, so now we're going to look at reflections across other lines. So this says to reflect the rectangle FROG across the line y = 2. So you can see on this graph that my x-axis is here and my y-axis is here. And this line is the line y equals 2 because it has a y-coordinate of 2 all along it. So this forms a horizontal line. So instead of reflecting it across the x-axis or the y-axis, we're going to reflect it across this other line, y equals 2. The method is still the same. Look to see how far away each point is from that line and go that same distance away on its opposite side of that line. So like F is 2 below, so I'm going to make F be 2 above for F prime. R is 2 below, so I'm going to make R be 2 above for R prime. G is 1, 2, 3, 4, 5 below, so I'm going to make it 1, 2, 3, 4, 5 above for G prime. And O is 1, 2, 3, 4, 5 below, so I'm going to put O 1, 2, 3, 4, 5 above the line, O prime. And this makes my new rectangle. Be sure to put primes on each letter and be sure to label each letter when you make your reflection. All right. Now, this says real world transformations. An ice skater gliding in one direction creates several translation transformations. Give another real world example of a translation. So remember, the translation is the slide. So what is an example other than an ice skater gliding along the ice of something in the real world that is sliding? Maybe a car rolling on a straight road could be an example. Or maybe a child going down a slide. Or maybe, let's see. Maybe even someone sledding down a hill or skiing. Sledding or skiing down a hill. So you could probably come up with some more examples, but that's just a few that I could name. Really, you only had to give one for this problem. Now, number 2 is the rotation one. So I'm going to come back to that one when we talk about rotations next time. And number 3 is reflective symmetry. A butterfly has reflective symmetry. Give another real-world example of reflective symmetry. Well, a person has reflective symmetry. You kind of have a vertical line of symmetry on you. I know sometimes we're not exactly the same, the left and right sides, but pretty close. Something else that has reflective symmetry, something that if you folded it in half, it'd look the same on both sides. Perhaps a book, although the words wouldn't line up, but the basic shape is the same on both sides. Something else, maybe like a heart, like the shape that you draw when you're, making a basic heart shape. That's got reflective symmetry. It has a line of symmetry going right through the middle of it. Okay, so I'm sure that you could come up with a lot more examples, but it just really needed you to give one. All right, now this is the last activity. It says use the given figure and the line of reflection. Draw the image in this line using a ruler. So here we're making an image where it's not on the coordinate plane. So if I look, this is down about 1 1/4 symmetries, 1 1/4 centimeters. Maybe right here would be B prime. D prime is on the line, so it's gonna just lie on top of the original point. C would probably be about right here for C prime. And then A is at 1 1/2. So right about here. And if I connect these, I make the reflection across the line, not on the coordinate plane, okay? So now number 2, we're reflecting this trapezoid. So I'm trying to get it as accurate as possible, but it's probably not going to be perfect. This isn't art class, it's math class. So we do the best we can with the tools we have. Looks like 1.7 centimeters. So that would be about here. K prime. L prime is going to be about here. And then M looks like it's about 1.7. So right here, M prime. So if I connect these, I should have a reflection of the trapezoid across the line A. Okay. Number 3, Y prime is going to be on top of Y, and Z prime is going to be on top of Z because those fall on the line of reflection, the line M. So I really only need to reflect 2 points here, which is nice. We just need to reflect point W. So 1.7. Oh wait, is that right? No, I measured that wrong, 1.2. So I'm gonna go down here, 1.2, right here. W prime. And then X, I believe, yeah, it's the same, 1.2. Try to come straight down. 1.2. X prime. My pen's kind of inky, it's smearing with my ruler. All right, there's my reflection, and one left to go, number 4. So I'm measuring how far is point U from the line K. It looks like it's 6 or 7/10 of a centimeter. I'm going to call that 7/10 of a centimeter. So I'm going to go over here, mark it to the right side, U prime. T is 1.4 centimeters. 1.4 centimeters. T prime. Connect those. And then S prime will lie on top of S because it falls on the line of reflection, line K. And then we just have point R is the last one. Looks like it's 2.1 centimeters long. So right about here would be R prime. And then I'm going to connect. There's my reflected trapezoid. Okay, so you've got some homework practicing with translations, which are slides, slides, and reflections, which are flips. Okay? So work on that. Let me know if you have questions, if you need help. I'd be happy to assist you, but good luck with your assignment, and I hope you have a wonderful day. Bye for now.